Did you know that some of the food we consume on a daily basis have been tampered with? How are you able to determine if the oil or the rice you consume every day is adulterated or organic? In this episode of RnD-Africa, the team visited the University of Cape Coast to speak to a lecturer and a professor who has developed a device that has the ability to test out the quality of rice, oil, and many other foodstuff. This is coming to you from the Department of Agriculture within the university campus. My name is Maame Ekua Otuakoa Nyame. Join me and let's do this together.
I am Teye Ernest in the University of Cape Coast in the School of Agriculture, but specifically in the Agriculture Engineering Department. And I'm the inventor behind rapid detection of food integrity, specifically rice, palm oil. Now we are into honey and others that are challenged to the Ghanaian consumers. When the news about plastic rice happened, and we know importation of rice into Africa is huge, that means that the market can be flooded with substandard quality. So I propose that we should use a mobile phone with the near-infrared spectroscopy to see if we can detect the rice on the market before it goes beyond the market to consumers. So in that instance, we got partners, and then we were able to develop the model into the mobile phone, so that with your mobile phone and the scanner, you can scan rice and it will tell you whether the rice is from Vietnam, from Thailand, from India, from Ghana. So with this, you will be able to know where your rice is coming from. And again, rice has different brands, high quality, mid, depending on the price. The technology was also able to identify high quality from mid quality and low quality. So that's what we have done so far for the past, let's say from 2018 to now. During my PhD, we use what we call near-infrared spectroscopy. It's a big machine, and it specifically works like the Rama. When you are pregnant, you go and they scan, they can tell you whether it's a male or female. So that same technology was borrowed to be used in detecting food integrity. So graciously, a company made a miniaturized form, which is like two of my fingers, but it works in so many fields. So I decided to use that same technology to help African food integrity, look at how we can use it to detect the quality, the safety of food in real time and also on the market, so that we can get the results before consumers take the food. The device came into reality around 2016, but the idea to use it came from me, and it started from 2017 when we heard of the news of plastic rice. In Ghana, the interesting thing about this device is that instead of taking the sample to the lab where it will take you, say, 2 days to get your results, when you're able to train this device, you get your results in less than 2 minutes. So that's the strength of the device. And as well, it doesn't destroy the sample. That means that you take it with your scan, you can take the sample back. So that is how we've been able to build this technology into the mobile phone by developing what we call chemometric algorithms that work best for the challenge we were solving. That was the rice integrity challenge. Consumers find it difficult to be able to detect rice from high quality, low quality, even rice from Ghana, rice from Vietnam. So what we did was to be able to build and train the technology so that we'll be able to identify rice from high quality and low quality, and not use consumer perception, because perceptions are not objective, they are subjective.
With regards to the rice, I am one who most of the times takes the foreign rice. Yes, I hardly take the local ones. Yes, but then with the foreign ones, how to detect whether it's fake or original, sometimes it's very hard. So we usually use the taste and then the color. Come say yes, because it's not in the market you're going to open the rice to check the color and all that, unless you get home and you've already bought it. So when you come in and it's cooked, the taste will probably maybe help you differentiate between the fake and then the original ones. But I think it's very hard determining it, because they come with same kind of label. It's very, very hard.
want to demonstrate the detection of the rice integrity. We have this rice, we are sure maybe it's from Ghana or local. This rice, we also know where it's from. We know it is from Vietnam, but we want to use a model we have developed using this handheld portable spectroscopy with a mobile phone and check the authenticity of the country in which the rice is from. So we will fetch it into a Pedrick dish and then take the first fingerprint and go straight to our mobile phone to get the results. What you need is that you need to on the spectroscopy. It's connected by Bluetooth, and the phone must also be connected to an internet source so that I think you can get your models in the cloud. Wonderful. We have this rice. Then you put the rice on the scanner, just like this. Then you click test model, because whilst we were building the model, we tested it for 5 times. We need to scan 5 times. So this is the first sound. And it's pretty easy. You just open the app, then go to test. You click on test. So first, the second sound, so we go third. We want to do 5 times. Then this is the third one. You go to the fourth one. This is the fourth scan. Then the fifth scan. So after scanning 5 times, what it actually did was to pick the fingerprint to go to our database to see whether this matches, and the results are in. So when you check on the label, where was it from? It's Vietnam rice. We don't want to sell any brand, but on the label it's written Vietnam. Now we go to what we call the quality status. Now when you go to the quality status, because of the price of this rice, it is indicated mid quality. Mid quality means that the price range and the quality per the sensory is not of a high quality, it's also not of a low quality. And that's where the results you can see, it says it's mid quality. So this is just very simple. Within less than maybe 20 seconds, you have your results. That is for rice integrity. Let's try the other one where we were anticipating it was from Ghana. Pretty simple. You just pour the rice into the Pedrick dish. You point it to the scanner. So you go back, then you click on test model 1, second, the third, the fourth, and then the last. Okay, so we are waiting for the results. Country of origin? Ghana. People they will put it at their nose to check. You can be deceived because somebody can just put perfume. And so you'll be thinking, oh, this one is local. So perfume is not the only answer. You have to go beyond the sensory and then do the spectroscopy where it goes into the molecule to see how the structure looks like. And then you get your answer in real time. And this is less than 30 seconds.
We were here some years ago when Professor Ernest Teye visited us at the market with his students. He came with a device, but we were not aware it was a device for the detection of rice quality. He told me that he wanted to test out the quality of the rice I was selling. He also told me about how plastic rice is sometimes mixed with the original rice and pushed to the market. He used the device on the rice and he showed us how to use the device. Unfortunately, after he left, we have not had any other way of detecting the quality of our rice until today.
Rice is mainly carbohydrates, and people will want to add various things to make it appear that when they say it's perfumed or something. But all these things are also, most of the time, they have to add synthetic chemicals anyway. And all these chemicals build up in your body. They are synthetic. Your body is not used to it. They bind to your body. Naturally, your body would have washed them off, gotten rid of it, excreted it. But these ones are not easily done away with. And so what happens is that they also build up with time in your body. And so you begin to see effects on the, let's say, how your body even handles glucose, which is implicated in how diabetes even starts. So all forms of adulterants, adulterations of food are very dangerous to the body in the long term.
My customers detect the quality of the rice they consume by taste. It is the same for market women. We detect the rice quality based on its taste and customer complaints. We used to have a problem because the rice used to be packaged in sacks, which made it very easy for others to imitate their brands. Later, the packaging was changed from sack to rubber, which to an extent makes it difficult for others to imitate the brand. Some people buy the original rice and mix it up with the fake ones. In return, they earn a lot of money from this venture.
Very difficult determining fake and in original rices, but then I believe that if we could get, or if there's any device which is going to help us detect the original from the fake, it will be a very great initiative, and it depends on how portable it will be, so that every single person in and outside could take it along anytime you're going to shop rice.
I paid them device and was about.
I would like to purchase one of the devices when it is on the market because some customers tend to complain about the taste and quality of the rice we sell, which is very challenging for us. Once I have the device, whenever I go to the market, I will open a bag of rice and test it out before I purchase them because the complaints are a lot.
The device and the usage is very simple, less complex. I always say that if you can operate a mobile phone, you can operate the device. Again, the device is very portable. It has even moved from being portable to a pocket size. So it can actually be in your pocket, and the device has something like a software you open on your mobile phone. It works by Bluetooth, so the device is connected by Bluetooth. And anywhere your mobile phone can work, the device works because it's linked to your mobile phone, linked to the internet, a cloud base. And then when you do your analysis, you are off. So it's just a matter of clicking. So if you are able to give somebody a 2 minutes, 5 minutes orientation, he should be able. We tried this with the market women. Well, when we went to about 3 markets in Ghana, and then after 5 minutes demonstration, we asked them to do, and they did fantastically well. So what I would say is the device could be used by anybody that uses a mobile phone.
We will test out the quality of the rice we have here. This is Gino rice. According to its labeling, it is produced in Thailand, and we are going to use the device to verify the quality of the rice. I will start by opening the rice, and then we will use the device to test out the quality of this rice.
From the review I did, the device can be used from agriculture, food, medicine, mineral, petroleum, and other aspects. All you need is the basis and understanding of chemometrics, and that's what I have. So with me, when I also heard of Sudan dye in palm oil during one of our meetings in the UK, they said Ghana, they've detected palm oil had Sudan dye since 2005. The solution has never come. So I decided, okay, let me see if palm oil without Sudan dye has a unique fingerprint. Palm oil with Sudan dye also has a fingerprint. That means they are unique. So I decided to investigate their uniqueness, and then we got that they were entirely different. So with this, we can say our technology will be able to, we proposed that the technology, because we did it in the lab, and it worked perfectly well. It can differentiate palm oil without the dye with palm oil with the dye for now, because we will go on to even do quantification. And the reason why this is a breakthrough is that since 2005, if those who consume Sudan dye, you'll be having challenges with your liver and your kidney because it's highly toxic. It is category 3 carcinogen. That means that if you take palm oil without dye, you'll be damaging some essential organs in your human body, which is not good at all. I am not sure those who are doing whether they are aware of that, but it's very harmful. And because it is very harmful, it is no. You don't even say we have limits of it should be no. It shouldn't be in palm oil. So we want to check whether this oil has Sudan dye or not. And it's very quick. We just pour it into the Petri dish. You can also try it in a small beaker. And then you put it on the scanner. Perfect. Then you go to the app, you open it, and then there are a lot of models. So you go to palm oil model, then it will open up. After that, make sure the scanner is on and is connected to the Bluetooth, connected to the phone. So you just click on it. As well, we scan 5 times. Is it adulterated or is pure? Yes or no? So our first result is in. Now this one as well, level of adulteration, it says pure. And this we are sure of the source, because we went to where they were doing it. So we are very sure of the source. And when it proves to us yes or no, we now take this sample to the lab and then we'll conduct a verification. So we verify this with HPLC sophisticated machine. That one will take you like 2 days to get the results. But this one in real time, you say it's a pure palm oil.
Food adulteration is a very complex one. FAO and all major organizations all over the world have tried their best. Clearly, it is not an issue that one sector can handle. I know the food and FDA in Ghana is doing a lot about this issue. So clearly it's multi-sectorial. We have to get the regulator involved. We have to get the people well educated to know what to look out for when they are going to buy these products. We have fish and meats that are also sprayed with a formalin to make it appear fresher. So what you have to do first is to educate the people as to what to look out for. The major challenge with our environment or our industries is that most of it is not regulated. Those who produce Zomi, for instance, they are not, most of them are not directly under the umbrella of FDA. So we have to make it possible. We have to encourage them. I know FDA has a system to register cottage industries, for instance. We have to get them registered, because what you must also know is that some of them do it unintentionally. It's accidental contamination. So if they get trained, we might reduce the incidence of food adulteration.
I have been selling palm oil for over 10 years now. Whenever I visit the market to purchase my oil, I pour them in gallons in order to check its color and quality. When I detect any other difference, it is an indication that there is a problem with the oil. There are times when I am able to detect the quality of the palm oil I buy, but sometimes I am unable to. If I have access to the device that is able to detect the quality of oil being sold on the market, I will take it with me whenever I go to the market, because it will help me detect whether or not the oil I am buying is of good quality.
The number of people that came together to develop the device comprises of about 5. And the 5, we are scattered all around the world. One from Africa, that is myself, one from India, the other from China, the other from Vietnam, the other from UK. So we are actually 5. But later on, we decided to bring others on board so that the technology could go far. That is, we added consumers from other countries as well, from Nigeria, Cote d'Ivoire, Ghana. Because the rice value chain, we saw that West Africa imports a lot. So we added even consumers at some point. We added importers at some point. We even added the police service and the FDA, so that the whole chain will have all the players in the rice value chain to be able to embrace this technology. So that's what we have done so far. We've not advanced in commercializing this technology. The reason is we don't want to be the brain behind this commercialization. It's like making a gun and you commercialize a gun and then you sell it privately. It's illegal. So we've made the technology. We want to give it to the law enforcement agency, like the FDA, the Ghana Standard Board, even the military, the immigration, to use this to protect the integrity of our food. So this is where we want to take it. It should be a government approach, not an individual approach. Other than that, you will not be able to achieve the ultimate aim of protecting the integrity of the Ghanaian food or the African food. We need to do that. If we can do that, it's government that must come in. So we have approached them. We are still waiting that they give us a green light, and then we'll train them, and then it will go on. So in partnership, what we need is that we need people to embrace this technology. We've contacted a lot of organizations. FDA Ghana, We also went to Nigeria to talk to their FDA, because this will help the FDA, because you are putting a technology in their hands to be able to do market surveillance. Instead of bringing the samples to the lab to come and test and tell you the result, they can do a random scan and get suspicious sample, and then they will take those samples to the lab to confirm. So we got the FDA. We also even engaged the immigration, because rice comes into the country. We also had another collaborator, fantastic one. It's called LGC, UK LGC. They are the UK government chemists, because UK they also had a problem with what we call the horse meat scandal. They are very much into looking at traceability of food. So UK government chemists came to Ghana, we met, and we consolidated our findings, and now we can say that these are some of the people we engage. As well, we also engaged a lot of the rice processors and importers. We even had a workshop where all these players were brought together under one umbrella, and then the demonstration was done, and most of them brought their comments, which was also incorporated into our technology to make it even better. I heard a word that says that you get money for solving a problem. So anytime you see a problem, you've seen money. And I got this from my Chinese professor. So that means anytime you see a challenge, you are actually getting an opportunity to make name, to make wealth. The typical one is Joseph. When he had problem, when Pharaoh had a dream, he interpreted the dream, solved the problem, and he became #1. So that means that I also got the problem that our food is insecure in some way. People are adulterating palm oil with Sudan dye. People are selling substandard rice. People are eating all kinds of food. So how will I be able to help them? At the backdrop that Ghana and Africa as a whole, we have challenges with our labs. Our labs are not resourced. Even if they are resourced, they are located in the capital cities. That means that food from other places, if we don't take care, it cannot be tested. Again, the testing technologies that we have in Ghana, in Africa, is robust, but it's very expensive to do analysis. So how can we solve this? We can do that through the application of artificial intelligence or sensor technology coupled to chemometrics, and that is where my strength is. So anytime I hear of these challenges in the food value chain, it gives me the opportunity to bring innovation. And we've done that for pineapple, organic pineapple, and conventionally grown pineapple. Because organic pineapple is expensive, people try to sell conventionally grown pineapple as organic. Now we have the technology that can detect. We also came to the challenge where people were selling eggs that are older. So we have what we call the mark date of lay on the eggs. If the egg is, let's say, above 9 days, the whole unit or the freshness goes down, and it's not too good.
Thank you very much to you, our lovely and cherished viewers, for staying with us in this episode. And as usual, RnD-Africa promises to bring you innovations and inventions coming in from Africa. My name is Maame Ekua Otuakoa Nyame. This is where we end the episode. And of course, if you are an innovator or inventor out there, kindly contact AAU TV and let's put the spotlight on you. Bye.